So welcome to our presentation. Our team name is Minerva. Kind of old school, but first I want to introduce my team members. It's Gregor Breckman, Martin Munich, Jan Friedrich Köhler, and me. My name is Kirsten Schäfer. And yeah, well, I'm sorry, kind of tricky. Yeah, we are from THM. It's a university in Frankfurt. What is our project about? So we tried to optimize the flight routes of our multi-rotor UAV, which is behind you, for photochromatic building and infrastructure surveying. So to build these buildings or infrastructure in 3D, increase quality of this photochromatic and increase time and energy costs. Where we want to use this is in building survey and construction monitoring, as well as in recent revisions. So I give it to Jan. He will presentate our tool programmed in Dynamo.
We had this problem earlier, so I had to go back. I try to speak quite loudly so that you can hear me.
Yeah.
Come back in front at the beginning. Okay. So it's a Dynamo solution. For our example, we used a quite simple building model. As you can see here, it's a normal house. But in general, it does not have to be a house. It can be an infrastructure or anything from which you can extract a surface. It's a general, important thing. This is a basic house we wanted to use, for example. And in Dynamo, we have two main inputs. There are few variable inputs, but they are not so relevant. The most relevant are the model elements which you can select and the focal length of the camera which is used. So 24 millimeters is quite wide, and when you zoom in, the image gets smaller, and this is implemented in the Dynamo script. So it's quite huge. It was getting very late yesterday, and we had some vector problems, so some re-implementations from our viewpoint were necessary, and so on. So there's really hacking, and I think this way a hack has to look, but it should work. I select the model elements. It's easiest from the one. Sorry. So I select nothing, switch in Revit to the first level, and back to Dynamo I can select the model elements. For example, this front facade of the building, but in general it's not important which facade you select. Then you can see the result from the top view, which is from our view the best path the drone has to fly to make good photogrammatical results. As you can see, the idea is that these are the points where the drone shots the photo, and the idea is that this point has a direction, the draw direction of the drone, and has to be orientated as a normal to the surface which is covered. This is the general constraint. And you can see it's more or less a spline which we developed for the drone, and not only in 2D but also in 3D. And this is how such a flight route of the drone could look. We start in the top right. The idea is it's more energy efficient to fly with one, to accelerate one time and fly up, and then fly the flight path over the whole building or the infrastructure and so on. So you can transform the coordinate system, then you can look down and so on. And it's a dynamic tool. So when you do a modification in Revit, of course, the tool, so the flight path, adapts to the modification. You can change the air wall, the tool changes, or even you can change the height of the building. You can see that the flight paths are generated dynamically. It takes a while, but in general, we have the more or less optimal flight route. And for example, I changed the focal length in our Dynamo script. 24 millimeters is quite wide. You should use about 35 to 50 millimeters for optimal results in photogrammetry. That was the developers of the software tools say. So you can do that. Then you have to take more photos, but the quality of your model, so the point cloud, which is the result, gets better. So 45, for example, the recalculation is done. You can see in the model that there are more points, better and 3D. More points, better quality of the resulting model. This is the first approach of the whole thing, so we are using the facades. Next idea is what to do when the building has a more complex shape or if the free form and so on. But the general approach should work with these surfaces too. I think it's the last 24 hours or 36 hours, a lot of hacking. Yeah, that's our tool we developed. Thank you. Perhaps as an add-on, it's not too late, I think. This is really a tool we wanted to use for surveying in a real use case. So we're doing as an institute such surveys of digital elevation models or even of buildings. And the next week we want to compare this optimal flight path with the real flight path the drone takes and overlay. This is energy optimized and wants to overlay the real flight path, so the logs of the drone with the results here, so they can read out the voltage and the power at every point, and then we can do further optimization in energy and time. Thanks. Okay, thank you. Are there any questions?
Same question, are you ready to share this?
Sorry?
So, same question, are you ready to share this in an open source?
Yes.
Yes, of course, no problem.
Hack community. That's good. Did you have a earlier experience with the Dynamo before?
I think it would have helped us. So as I said, we had some vector problems. We do not understood the logic, or it was too late yesterday in the evening, of the vector implementation, and it's more or less a simple school math, and we did a re-implementation. So yes, a little bit, but no further background.
Well done.
Yeah.
Have you looked at like some of the technologies that we have in order to do photogrammetry? Forge has access to a private beta of reality capture API, which has a main focus on the drone industry. So I guess you guys could apply as in like good candidates in order to test out this kind of functionality. It's actually pretty nice. We tried out the recap functionalities and so on. They were quite limited, so I don't know. We did not check it if the images are too large or too many images or not good enough or whatever. The results were, in some cases, beautiful, but in other cases, no results. We have 3D robotics being one of the customers that actually.
There is a Pixar controller inside, so there is some Autodesk in the drone already.
Yeah, pretty cool.
Okay.
Maybe just out of interest, do we know how an interface would look like between your path in Revit and the actual drone flying this part? Is this simple, or is it done?
In general, there's a quite standardized interface for the drone communication. There's a MUF-link interface. You could use it for that. I'm not sure if it's necessary. You could use this XYZ in jaw orientation and use it in a normal ground control station. So you can export it as Excel. It's in function Gregor implemented, and just use it in the normal ground control station. So Yes, it is. You can think about it. I don't know if it's necessary for a real use case.
It was just
No,
out
no,
of interest.
yeah. But normal serial communication is no problem to do it. Okay, thank you very much.